In today's session, we will be doing factor theorem. Now, as you are aware of value of a polynomial and remainder theorem, we will be going one step further with factor theorem. So I hope you remember the remainder theorem which said that if you find the value of a polynomial with a negative value of a divisor, that is nothing but equal to the remainder on division of that polynomial. So now, in lower classes, you must have learned, let us say 12 divided by 6. It easily gets divisible by 6. You get a quotient 2 and a remainder 0. So what we can say is 6 is a factor of 12 because it completely divides 12. Same thing is true for a polynomial also. That is, if a polynomial is divided by another polynomial and the remainder comes 0, then the divisor becomes a factor of the polynomial. So let's take some examples. Let us say we have a polynomial x cube minus 3x square plus 3x minus 1. And we have a divisor which is x minus 1. And we have to decide whether this x minus 1 is a factor of this polynomial or no. And the only thing that we should check is whether we get a remainder 0 or no. And we have seen how to find remainder 0 using a remainder theorem. That is, using the divisor which is x minus 1, we take the value of x as 1, that is opposite sign of what is present in the divisor, and we find the value of the polynomial using this value. And if we get remainder 0, then we can say x minus 1 is a factor of this polynomial. So let's go ahead and find the value of the polynomial. This is the polynomial. We substitute the value 1 in it. So we get 1 cube minus 3 into 1 square plus 3 into 1 minus 1. 1 cube is 1. 3 into 1 square is 1. 1 into 3 is minus 3 plus 3 minus 1. So you can see minus 3 plus 3 will get cancelled. Plus 1 and minus 1 will also get cancelled. And what you will get is 0. Now since the remainder, that is value of this polynomial is 0, which is equal to the remainder as per the remainder theorem. So now if the remainder is 0, that means x minus 1 is a factor of this polynomial. So when you will divide this polynomial by x minus 1, you will get 0 as a remainder. So this is what is called a factor theorem. What does the factor theorem say is that if you find the value of a polynomial using the opposite sign of the divisor, and if you get the value 0, which is nothing but the remainder, then that divisor is a factor of the given polynomial. Let us check another one. X cube plus 6x square plus 12x plus 8. This is the polynomial given, and we have to find out the divisor x plus 2 is a factor or no. So what we do is we take x as minus 2 and we find the value of the polynomial using that. So wherever there is x, we put minus 2. So minus 2 raised to 3 plus 6 into minus 2 raised to 2 plus 12 into minus 2 plus 8. So you know minus 2 cube is minus 8 and minus 2 square is 4. 6 fours are 24 and 12 and 2 is again minus 24 plus 8. So you can see plus 24 minus 24 will get cancelled. Minus 8 plus 8 will get cancelled and what we get is 0. So the value of the polynomial with minus 2 is 0, or in other words the remainder is 0. So if the remainder is 0, then x plus 2 is a factor of this polynomial. Right? Let's take another example. X cube plus 3x square minus 2x minus 6. And we have to decide whether x plus 3 is a factor of this polynomial or no. Now, as we have seen in remainder theorem, here also the divisor will be in the form x plus a or x minus a only. Under these circumstances only can we use this factor formula or the factor theorem. So let us find out the value of this polynomial. Since x plus 3 is there, we are going to take x is equal to minus 3. Let's substitute the values in this equation. So we get minus 3 cube plus 3 into minus 3 square minus 2 into minus 3 and minus 6. So minus 3 cube will be nothing but minus 27. 3 square is 9. 9 3s are 27. And this will become plus 6 and minus 6. So again you can see Both are plus minus, they'll get cancelled to give you 0. So again, we get 0 as the remainder. So now we can conclude that x plus 3 is a factor of this polynomial. If we don't get this as 0, if we get it some other number, some other integer or any whole number other than 0, then we can say that since the remainder is not 0, this divisor is not a factor of this polynomial. So for the divisor to become a factor of this polynomial, the remainder should come as 0. That means it should completely divide this polynomial and should not leave any remainder. So this is factor theorem. Now using this formula, we can even find the value of any variable which is not present in the equation. Let us say if it is given that x minus 2 is a factor of x cube minus mx square plus 10x minus 20, and the question says find the value of m. Now here the given condition is that x minus 2 is a factor. That means when I will divide this polynomial by x minus 2, the remainder that I get should be 0. So let's just first write the polynomial x cube minus mx square plus 10x minus 20, and divisor is x minus 2. So we take the value of x as 2. Let's find the value of the polynomial using 2. So wherever there is x, I am substituting 2. So 2 cube minus m, 2 square plus 10 into 2 minus 20. So 2 cube is 8, 2 square is 4, 4 into m is minus 4m, 10 into 2 is 20. Minus 20. Now we can see plus 20 minus 20 will get cancelled. What remains is only 8 minus 4m. So now this is the value of the polynomial when the value of x is 2. But now given in the question is that x minus 2 is a factor. It is given is a factor. So if it is a factor, that means the remainder should come equal to 0. Now this is the remainder. But the remainder should be equal to 0. The reason being is x minus 2 is a factor. So therefore what we can say, 8 minus 4m which we got as a remainder should be equal to 0. Just take 4m this side. So we get 8 is equal to 4m, or m ka value is 2. So using this factor theorem, we can even find out the value of any missing variable. So this is factor theorem, just same as the remainder theorem. Only here is that we are not interested in getting any particular remainder. We are interested in getting 0 so that we can decide whether the given divisor is a factor of the polynomial or no. Thank you.